But now we're getting into single replacement reactions, okay? Single replacement reactions. All right. So this is where your test references are coming back into play again. Because when I said in that definition, the activity series, well, you'll find that right here. So this is the activity series of metals here, and the activity series of halogens is down here. Okay? So, a metal in this column, a metal here that's higher, if it's by itself in the equation, will replace a metal here in a compound, but only if the metal by itself is higher than one of the compounds. Okay? Hydrogen is also in this list, so metals can also replace hydrogen. Okay? And that's what happens when you have a metal reacting with an acid. Okay? All right? So let's take a look at some equations and see how that works. Okay? Let's react barium the metal. Barium the metal with zinc sulfate. And you have to predict the products. This right here? That's a 4. Sulfate is SO4. Oh, this. No, that is the letter S. Yes, letter S. Sulfate is SO4. Okay? So we need to know about these two elements here, barium and sulfate. Okay? And we'll look on the activity series here, and we can see that barium is right here next to my finger. Okay? And the element that's like it in the compound would be zinc. They are both metals. So we're talking about like being metals replacing metals, or metals replacing hydrogen. The metal that's by itself as the element that's by itself as a metal, so it can only replace metals or hydrogen. Okay? So looking on the activity series, barium is higher than zinc. Okay? And the zinc in the compound is zinc with a 2+ charge, and that's what's in this second column, zinc with a 2+ charge. Okay? So barium can replace zinc. We therefore do have a driving force, and therefore we will have a chemical reaction. Does that make sense? Or at least that's the prediction. Okay? So if a chemical reaction will occur, then I can replace the zinc with the barium. So the barium can go over here and kick the zinc out. All right? So we'll have barium sulfate as a product. Now that's not a balanced formula yet. Might be. We're going to find out if it is. And we're going to have the zinc over here all by its lonely little self. Okay? No. Doesn't matter whether zinc is written first or barium sulfate is written first. Now before we go any further, we want to stop and make sure we balance the formulas. You cannot balance an equation unless you first balance the formulas. Everybody hear that? Mm-hmm. That is really, really, really important. You cannot balance an equation until the formulas are properly balanced first. Okay? And if you don't properly balance them, there's a very good chance you won't be able to balance the equation. So we spent 1 unit and a good part of the last unit going through, reviewing how to balance formulas. You have to get the charges to balance out. All right. So we want to go for barium. Then where do we find its charge? What? Where do you find the charge on a barium? Periodic table of oxidation numbers. Okay. And here's barium down here. So what charge does it have? Say what? Barium?
You're looking at the wrong one.
Barium. 2 plus down here. 2 plus down here. 2 plus. Okay? Alright. Yeah, BA stands for bad attitude. Okay. What? That was, remember Mr. T? That was his name in the what was that TV show? A-Team. He was BA for bad attitude. Okay. Alright. Alright. Okay. Alright, so that's a 2 plus. So barium has a 2 plus. Now we want to look for the charge on the sulfate. Where do we find that? Huh? Where do you find sulfate? The common ions list. Okay, and sulfate's right down here. You see it? Right there. It has a 2 negative charge. So in this case, our life's a little bit easy because we've got a 2 plus and a 2 negative. That's a 1-to-1 ratio that we need here. So this is basically already balanced. I need to know what physical state it's going to be in. Okay, now we'll get to the physical states when I do double replacement reactions because we're going to figure that out from the solubility rules. Okay. For now, I'm going to go ahead and tell you it's aqueous. Well, wait a minute. Hold it. Sulfate, barium sulfate may not be. Let me double check that. I'm thinking barium sulfate is an exception. And indeed it is. So this is going to be a solid. Okay? Now, zinc metal. What physical state is it going to be in? Yeah, metals are solids, aren't they? Unless you really heat them up. They're solids. And we're running all these at room temperature. You assume it to be in lab temperature. Okay? All right. So now we have an equation that we have not yet checked to see if it's balanced. What do we use to balance an equation? Atom inventory. Okay, now I've given you a fairly simple one where it already is balanced to start. Okay? Yes?
So if barium and sulfate cancels out, we can automatically put them together?
Yeah, you can think about it that way. If the charges on the barium ion and the sulfate ion are the same, in the number's the same, but the charge is opposite, then they're canceling each other out. Okay? Technically, what you're doing is you're adding the 2 plus and the 2 negative and getting a 0 charge overall. Okay? Now, you need to know that even though I've given you one that's already balanced, on a test or homework or classwork, you've got to do an atom inventory and prove it to me, because I'm from Missouri. You have to show me. Yeah, Missouri's the show me state. I'm not really from Missouri. I just say that all the time. Yeah, well, at least you live in South Carolina. So, okay.